All right, now we're going to talk about section 13.2, which covers a special type of sequences in series, and those are arithmetic sequences in series. An arithmetic sequence is a sequence in which each term after the first term differs from the preceding term by a common number, a constant, called the common difference. So the common difference for the series 1, 2, 3, 4, 5, the common difference, we call this D, is 1. We can see it's increasing by 1 each time. The way we find our difference is we take one of our terms and multiply and subtract the one behind it. Okay, so for here the difference is -3 minus -9. So that is a -3 plus 9, so I have 6, right? We're adding 6 each time. And it's important to check each of these to make sure that the difference is always 6, because if the difference was, say, we had the sequence -9, -3, 3, 8, here the difference isn't 6, here it's 5. So this would not be arithmetic. But this one is, because the difference between -3 and 9 is 6, the difference between 3 and -3 is 6, and the difference between 9 and 3 is 6, and so on and so forth. That's what these ellipses mean. So let's find the common difference of the sequences in series. The difference here would be a sub n plus 1, 5, minus the term before it, 4. And we want to check the rest of them. 9 minus 5 is 4. 13 minus 5 minus 9 is 4, right? So this is an arithmetic sequence with a common difference of 12. This is an example from our first video, right? And we found that the difference here was 12. But if you can't see the difference or you aren't sure that you have an arithmetic sequence, it's important to check those values. 13 minus 1 is 12. 49 minus 37 is 12. It's always important to check your work. But sometimes you will just see it, and that's okay. So let's find the first 5 terms for the following sequence. So my first term is 7, and the common difference is 5. So a sub 1 is 7. That means my a sub 2 would be 7 plus 5, which is 12. A sub 3 equals 12 plus 5, right? Because remember, this is recursive. This is like a sub 1 is 7, and a sub n is a sub n minus 1 plus 7, right? This is a recursive definition right here. So a sub 3 is 17. A sub 4 is 17 plus 5, which is 22. And a sub 5 equals 22 plus 5, which is 27. All right, let's take another look at this. This one is recursive as well. I have a sub 1 is -12, and I know my difference is -4, so I'm going to have a sub n is a sub n minus 1 minus 4. So a sub 1 is -12. A sub 2 is -12 minus 4, which is -16. A sub 3 is -16 minus 4, which is -20. A sub 4 is -20 minus 4, which is -24. And last, my fifth term, a sub 5, is -24 minus 4, which is -28. Okay? So these things build upon each other. Now, wouldn't it be nice if there was a shorter way to figure out, say, what if I wanted to know what my a sub 10 was in this case? What if I want to know the 10th term of the sequence? I don't want to have to go through and calculate a sub 6, a sub 7, a sub 8, a sub 9, a sub 10, right? That's a lot of math. So much math. So luckily for us, when it comes to arithmetic sequences, there is a shortcut. And the shortcut is this. If I want to know, if I'm given an arithmetic sequence and I want to know what the a sub nth term is, I can take a sub 1 plus n minus 1 times the difference. So in order to find a sub 13 for this sequence, I first need to determine the difference. So I'm going to take 1 minus a negative 3, so I get the difference is 4. So then I know that a sub 13 equals a sub 1 plus 13 minus 1 times d. So let's go ahead and substitute in all the pieces of information I know. I know a sub 1 is negative 3. I know my n was 13. And the difference is 4. So now I have a sub 13 equals negative 3 plus 12, 13 minus 1 times 4, that's 48. So I have negative 3 plus 48, which is 45. So the 13th term of this sequence would be 45. This is a nice little shortcut, okay? Now, one thing we can also do is find the sums of a sequence, okay? If I know my first, so a sub 1, and my last term, a sub n, then I can find the sum of the first n terms by giving the following. So S denotes the sum. So the sum of the first n terms is n divided by 2 times a sub 1 plus a sub n. So let's go ahead and look at this example. I can find the sum of the first 10 numbers by taking n over 2, so 10 divided by 2, times a sub 1, which is 10, and a sub 10, which is 5.5. Okay, so I have s sub 10 equals 5 times 15.5, which gives me 77.5. So the sum of the first 10 terms of this sequence is going to be 77.5. Now, what if I wasn't given my last term? What if I didn't know my last term? Then we'd use this equation, and I want to show you where that comes from. So in the previous slide, we had the equation to find the sum of the first n terms as s sub n equals n over 2 times a plus 1 plus a sub n, okay? Now remember, the equation for a sub n was this right here, a sub 1 plus n minus 1 times the difference, okay? So now I have s sub n, if I combine like terms, s sub n equals n over 2 times 2a plus n minus 1 times d. So let's go ahead and use this equation in an example. So I want to find the 11th term, but I'm only given my first term. So I have s sub n equals n over 2 times 2 times a sub 1 plus n minus 1 times the difference. So s sub 11 is going to give me 11 over 2 times 2 times a sub 1, which is 3, plus 11, right? Our n in this example is 11, minus 1 times our difference of negative 2. That gives me 5.5 times 6 plus negative 20, PEMDAS, right? We're multiplying that together. That gives me s sub 11 equals 5.5 times negative 14, which is s sub 11, which is negative 77. And I thought for myself the first time I solved this problem, I was like, wow, this number is really big considering we only have a difference of negative 2. But remember, we aren't finding the 11th term, right? This would be the 11th term. We're finding the sum of the first 11 terms. The sum meaning add them together. So just one thing for you to check yourself.